development. Oh, that's what I wanted. That's what it was. Okay. If you are interested in the difference between identical and fraternal twins, the difference between identical and fraternal twins is this. Identical twins come from one egg and one sperm. When a sperm fertilizes an egg, it donates its 23 chromosomes from it to the 23 chromosomes of the egg, and they then combine to form a cell with 46 chromosomes. And then they begin to divide, and each new cell gets 46 chromosomes. And they divide into a ball of cells that then becomes what's called a blastocyst and implants in the uterine wall. However, occasionally, during that 5-day journey down the uterine tube, occasionally, this ball of cells separates into two separate balls of cells. Breaks just about equally in half. And why that is, we don't know. We know there's a genetic predisposition to it, but we don't know exactly what the mechanism is. But we do know it has to occur between here and there. Because once these dividing cells then reach the uterus, they can implant in different places in the uterine wall and develop into two individuals, but genetically they're identical because they came from one egg and one sperm. Fraternal twins are the result of more than one egg being released. So if an egg is released here and gets fertilized by one sperm, an egg is released here and fertilized by a different sperm, now we have two sets of embryos developing, coming from each a different egg and a different sperm. Therefore, they're called fraternal twins. They could be the same sex or different sexes. Whereas identical twins, obviously, are going to have to be genetically the same and the same sex. So that's the difference between identical and fraternal twins, and it has to occur in the very, very early stages. Now, the stages of embryonic development, which is next on your outline, there are a few terms here in the early development of the fetus that have specific time frames, and they're important medically because these are referred to as specific time frames, and are also important in a court of law because the laws are written around these time frames. So the cleavage period is the first 6 days prior to implantation. So this is the cleavage period here before these dividing cells begin to implant in the uterine wall. The pre-embryo is from the 7th day, or from the first week to the 3rd week. It's classified as an embryo from week 3 to week 8. And during that time, the placenta forms, the umbilical cord forms, the amniotic sac forms. And once you get to week 9, it's classified as a fetus. So a fetus is a developing embryo from week 9 to birth. An embryo is from week 3 to week 8. The others, neonatal, the first 4 weeks after the child is born, infancy 4 weeks to 1 year, childhood 1 year to puberty, adolescence, puberty to 18 or sometimes 34, adult from 18 to old age, and senescence is old age. Those later ones I'm not that important. I thought I'd put them down because they exist, but the more important ones are through the fetal and neonatal. Those are the ones that are important from the standpoint of time frame and the law. Hormonal changes during pregnancy. This is just a little bit of repeat about HCG. Upon fertilization, the dividing cells from the fertilized egg begin producing the hormone HCG, human chorionic gonadotropin. The secretion increases rapidly during the first 12 weeks and then tapers off to low levels. Pregnancy tests detect the presence of HCG. HCG stimulates the increase in production of estrogen and progesterone by the mother, which continues until birth. The effect of this increase is to interrupt the 28-day cycle during pregnancy, and HCG also causes morning sickness. The 3 trimesters of pregnancy I'm not going to spend a great deal of time on, but there are a few things that are worth mentioning here. The first trimester is when all the organ systems are beginning to form, and therefore it is the most crucial as far as creating the optimal environment for the fetus. Alcohol, smoking, and drugs then can have significant effects on that period of time that show up later in fetal development. 75% of miscarriages occur during this period. And a majority of these miscarriages are nature's way of stopping a pregnancy that will never reach full development. And it's important to understand that particularly during first pregnancies, miscarriages are relatively common. And again, miscarriages occur generally during the first trimester. And most all the time, it's not the mother's fault. Most all the time, it's because of some genetic mishap. And that's, like I said, just nature's way of stopping the process before it reaches a later stage that's unviable. The second trimester, organ systems are completing their development. The fetus is taking greater control of the mother's body. And the third trimester is the most demanding on the mother. The fetus gains 70% of its weight during the last 3 months. Taxes the mother's cardiovascular, respiratory, and urinary systems because the fetus is passing those through to the mother's circulatory system. So she has to not only take care of her cellular waste, but the fetus's cellular waste, her carbon dioxide, the fetus's carbon dioxide, etc. High levels of stress can increase the chance of premature labor. So those are the general concepts of the first, the 3 trimesters. Any questions about any of that? I have a video that I forgot to bring with me, so I'll go get it and bring it down, that goes through a mother's pregnancy. But this is different than probably some of that you might have seen before, because it really relates to how the fetus affects the mother. It doesn't dwell so much so on just what's going on developmental-wise with the fetus. So I think you'll find it relatively interesting. So I'll grab that and I'll be right back.